First, hello everybody. Okay, my name is Jiun. Okay, as you can see lah. Okay, Jiun Physics. So what we're doing today, simple. Now the target for today mainly is chapter 2. Okay, now of course you need to understand one thing. Chapter 2 is very long subtopics. Chapter 2 has a lot of subtopics. Chapter 2 has quite some chapters lah. Alright, so I will not be able to do a whole chapter 2, of course. Now we in 2 hours, if I can finish chapter 2, then we basically be on a rocket all the way, fly lah. Okay, because the main thing is I want to do revisions about your chapter 2 because you guys having exam, right? Some of you say, oh, I done already first term. Now we refer to second term actually, because a lot of you have like monthly testing, just a few subtopic being tested. That one not consider lah. We're talking about a serious one that you actually write your result into your report card one. So I think everybody have this midterm coming soon, right? Different timing lah, of course, everybody exam. Some of you June, some of you July, some of you say August, right? Well, that will depend. If your exam is June, then perhaps lesser chapter will come out because you see, based on you tell me your teacher until free fall only, your teacher until momentum only, right? So we follow progress lah. So that's why, and the main thing about revision is what? We revise things you've forgotten. Okay, meaning what? The front chapter, right? Because meanwhile, now you are learning the back part of chapter 2, impulsive force, momentum, and then some of it is just finished, right? So the back part of chapter 2, I most likely not gonna go through too much, right? Mainly we focus on to the front part, okay? Because front part is the one that you forget, and then front part is normally where most people are more blur. Why? Because you just only learn like from 4, you just started chapter physics. Okay, this chapter are still new to you. This subject are still blur to you lah. So that's why most people have problem with the beginning part. And of course, when your beginning part is good, right? When you go to the back part, it will become easy for you as well because you can pick up easily, right? So what we're gonna do, the front part. Now, I want to do more lah. The more, the better lah, of course, right? Because the more I do with you, the lesser you have to study yourself. But definitely the notes I provide for you, right? Inside has a lot of questions one. Because mainly it's, I memang prepare more one, like extra just in case for you to do more. Okay, you say, oh, you give me until momentum, but why you never finish momentum one? Simple, because the extra exercise is for you to practice. Because some of you say, I got no exercise book, how? I got no things, I don't have any material to do reference. Never mind, I prepare for you, you do. Okay, the exercise inside is actually very good. Yes, those are designed to be like, exam style questions. Because a lot of you, right, you just only read. You read your textbook, you study, but you don't know exactly what they come out in exam. You don't know what they test you in exam. That's a problem, right? So that's why I show you exam style questions, what they ask, how they ask. A lot of you just say, oh, is it physics just calculation, maths? No, calculation is only part of the question. Let's say we say question 1. You have like A, B, C, D, right? So A is calculation. But the rest, you got a lot of things, but can know a bit of theory. They ask you explain this, explain that. They ask for definitions, right? So everything packed together become one question, right? In exam, everything you have to know. Now, regarding definitions, right? You want to memorize or not? That one I'm not going to force you because I understand definition memorizing definitely need more time. You need to invest more time to memorize So that's why normally I recommend what? You do exercise more, okay? Calculations theory whatever. After you finish all those already, right? You got time, you go for definitions. Now, I tell you what, definition sure come on in exam. But normally about 5 questions. 1 question, 1 mark. So you think about it. Your paper 2, let's say we got 100 marks. That being said, 5 question means about 5 marks. So you decide yourself whether this 5 marks is important for you. You say, hey, okay, 5 I can throw away. Then you make sure the time you save up for not memorizing definitions, right, it's to do other things like calculations or anything else. Rather than say, oh, I save up the time, I don't study this one, and then I slack at home. I just lie down and then I wait for time to pass. Then the one different story, right? So you save the time to do other things like calculations. Okay. Now let me show you our notes. Let me show you the notes. Some of, you all say you get it, right? If you haven't got it, right, just go to the TDC websites. You can get a PDF file first. There's a Google Drive there where you can download the file. Okay, you can memorize. You can print out if you want to, your choice Okay, so you say, wait for them to deliver too slow right? Sometimes a bit, this one memang a bit slow because for one reason, let's say we deliver to your house. Okay, and then let's say you are from other states, Kelantan, Sabah, Sarawak, Penang, Pahang, Johor, right? Then of course the one post Laju, we cannot control, right? They take sometimes. Okay, that's the thing. Okay, all right. So, nice background picture. You know who is this or not? In case you, you know who is this guy? I suppose everybody does, right? Quite recognizable by everybody, right? What is it? Who is it? Who is it? Newton. Hey, hello. Newton don't look like this, right? Newton looks like this. Last time, the older generation, they all like, looks like, you know, they all have like perfect hair, and then like, you know, the wig. This one, right? They wear wigs one. Yeah, like also thing one. Okay. Albert Einstein, correct. Newton's always got apple, correct. But I want to tell you one thing. You know the story about the apple fall on the head, and then say, oh, there's gravity. That's not true. Yeah, apple doesn't fall on his head. Apple fall in front of him. Yes, but of course, you know, they want to make the story like more epic, legendary. Then they say, oh, one day the apple fall on his head, suddenly discovered, oh, there's this gravity on Earth. It's not. Everybody, I mean, he started doing research about gravity already, actually, just that the apple kind of inspired him to move on. Okay, anyway, not important. Okay, Newton, this guy. And then just now we saw the Einstein. Now over here, chapter 2, title, Force and Motions, you all should know, right? And the thing is what? Chapter 2, let me dissect for you. I tell you what is chapter 2, what is important, what is the thing that you should study and everything. Right? Now, chapter 2, we separate into 2 parts. What is called force and motions means what? The front part of your chapter 2, right? It's about motions. Okay, think about it, what you learned before. Like in the early chapter, in the early subtopic, you got the 2.1, 2.2, 2.3, all kind of, right? Linear motion, ticker tape, motion graph, free fall. All these, you think about it, what do? You calculate velocity, you calculate accelerations, you calculate distance, you calculate displacement. So ultimately, what are those? Motion. So the back part of chapter 2, it will be force. Okay? So you say, hey, why are we not learning force first? It's force and motion, right? You think about it. If you want an object to move, what do? If you want an object to move, what do you need to do? You pushed it, exactly. Now, what does it mean by pushed? You apply force, exactly. So in a way, I can say force, they cause motion. You push something, they move. You push something, they accelerate. So of course, you have to learn this one first. If not, right, we do force first. After you apply force, the object move. Then the question asks you, hey, moving, right, calculate velocity for me. Then you're stuck. Because why? I say, I don't know how to calculate velocity. I don't know how to calculate accelerations. So this is why, right, we always learn front part first. So the notes I gave you inside actually consists of few subtopics. Okay, now first thing first, on the very first page, do you see this? Now, one thing that students always got these questions, you always tell me same things, I don't know how to start. I wanted to study one, but I just don't know what to start. Never mind, I give you a checklist. I give you a study guide. You follow this, you study. Okay, now this is not tips. And to be quite frankly, I don't like the idea of tips. When you are so used to tips, right, then you don't want to put effort on. And of course, are you sure tips will come out? You're just gambling yourself, right now. You just hope that I study this one come out. So that's why, right, I would rather simple. I tell you what coming up. I tell you what is important. Okay, this subtopic, what is the thing that you must know? Okay, of course, we narrow down the study range you have to do. But when I do that, you can follow. It's like a study guide. Okay, you think about it. Are you be able to differentiate what is distance, displacement or not? If you say yes, then you put a tick here. So over here, you have a checkbox. What you need to do ultimately is to make sure everything check. So it's like check here. Oh, this one I know. I put a tick. This one also I remember. I can do. I put a tick. So ultimately, right, what you want to do is all these check boxes, you need to make sure they are all checked up. All right, I can do this, I can do this, I can do this, I can do this, I move on. I can do this, I can do this, I can do this, I move on. Right, now this one, it's a checklist for you. You keep it to yourself. There's no need to lie about it. It's yourself one. So please make sure you really know, then no need to check. Yes, make sure you know what is happening, then no need to put a tick there. There's no need to lie to yourself, you understand? You say like, hey, tomorrow exam, but I haven't finished studying this. Never mind, I put a tick first. Then for what? You get it? It's like you are lying to yourself to make yourself feel good. But you know, deep down inside, you never finish one. You know, deep down inside, you don't know one. So you need to understand, this is not some magical charm, you take already, then your knowledge suddenly appear in your brain. Why got such thing one? I mean, if that's the thing, right? Then and literally, this is not I'm not teaching you anymore. I'm like a bomo or like a witch. I give you charm. All right, this one you take, and then suddenly knowledge comes. Of course not, right? So this is a checklist for you lah. And another situations where some people say, "Hey, I got study one. Okay, I study good, right?" So what happened is now, some people got this fear. You got this one problem is what? You don't know what you don't know. Okay, I repeat that. You don't know what you don't know. Okay, so you just study. You feel like, I should be okay already, but you're not sure. Okay, you're not sure whether is it really okay or not. You feel like, some part maybe I got study, but I'm not too sure. And then the biggest fear of yours is what? You scared, right? You go to exam. Now, before exam, half an hour, 1 hour, suddenly you got this one friend bring a question for you and then ask you, hey, how to do this? Then you look at the question like, hey, why? I never seen this before at all. Then two of you start to go panic. Look for books. You say, hey, shit, got another 30 minutes only. How? Now, simple. Here's the idea. I give you this checklist. It's for these purposes. You can check everything, you are safe. So if you go by yourself, I mean, you feel confident. You say, okay, I good already one. I know whatever I should know about this subtopic, I got already. So that is the point of doing this checklist for you. Okay? So this one, you keep it for yourself. And then every time you're doing revision, you study, you put a check. Get it? And then worst case, some of you say, hey, what if really happens? Like my friend come out, bring me this question. I really don't know how to do. How? Now I teach you one simple trick. If this situation happens, before exam, your friend bring you a question. How? Now you raise your right hand. Okay, you raise up your right hand and then you put your right hand on your left chest. And then you do this. And while doing this, right, you repeat one sentence. This thing won't come out on. Chill lah. Exactly. Now, to be quite frankly, what else can you do? You only got 30 minutes left. And then you see, the more you panic, the more you forget. And to be quite frankly, let's say that question really come on the exam. How many marks they going to cost you? 3? 5? That's it, right or not? So you would rather just give it away. Okay, give it away. 5 marks only, throw away. And then try to remember what you have studied. Rather than, because of the 5 marks, you panic, then you forget even more. Then 10 marks gone, 15 marks gone, 20 marks gone. Isn't it not worth it? So that's the thing. Number one, don't talk to your friend. Your friend comes say, I don't know, I very dumb one. Ask someone else's. You just study and focus on yourself, especially half an hour before exam. Do not talk to anybody. All right. Meanwhile, focus doing this. We good? Now, so what we have here, the checklist here, I actually prepared a few subtopics for you. You know what's linear motion, right? The very beginning of chapter 2, the front part, and then we got motion graph, and then we got inertia, and then we got momentum. Now, all these, right, actually under what? They are under your front part. As I said, force and motion, the motion part. Get it? Now, here's the thing. When I say linear motions, right, a lot of people say, hey, linear motion is 2.1. Actually, not true. Linear motion here, what I refer to, it's actually 2.1 and also 2.3. Okay, 2.1, 2.3, we put together. And then after that, your motion graph is 2.2. And then after that, inertia is 2.4. Momentum is 2.5. So I actually kind of cover mostly of your chapter 2, if you realize that. 8 subtopic. I give you 2.1, 2, 3, 4, 5 already. So this is your checklist for you to prepare for exam. Okay, then the back part, the 2.6, 7, 8, that one is your force part. That one, of course, we will not have time to finish. That's why we don't do. Okay, so here we focus. And to be quite frankly, there are some questions I definitely will not have time to do one. So regarding answer, simple. Okay, now you go to our website, right? Remember I said the place you have a Google Drive, you can download the PDF file. After that, I will upload the answer as well. Yes, every question got answer one. So don't worry about it. Okay, because some of you say, I wanted to try some essay questions. I don't know where to find it, right? Now, inside, I prepare all kind of questions. Exam style, explain, calculations, and some more we have like what? You see, essay questions. So inside every question, I give you answer. So don't worry about that. Some more you see behind, right? I some more got prepare extra exercise like, objective for you. Objective to quite frankly, okay? It's for you to kill time, man. Sometimes when you're studying, you feel like, hey, structure very boring. I keep writing. Never mind. You can do objective. Okay? You tell yourself, never mind. Today, right, I bring out the book, I bring out the notes, I just Do one question of objective. You say, one question objective? Is it useful? You think about it. You know you're not going to just do one question. The point is what? Is to lie to yourself. Yes, you want to constantly lie to yourself so that you keep doing. You know what is the hardest actually? It's not to study. It's to start studying. Realize the thing? Every time you study, right? What is the biggest challenge? It's the constant, your mind telling you, hey, you sure you want to study? So hard, so many chapters to do, right? Then your brain is convincing you not to study. So what you do now, you cheat your brain. You say, never mind lah, we do one question only. And of course, you know what? When you did question number 1, you somehow accidentally saw question 2. Then you lie to yourself again. Hey, why not we try one more? Okay, keep telling yourself one question only. Why not we try one more? 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 Ended up, right? You finish whole page already. You say, hey, not bad, what, right or not? Then you will slowly pick up the momentum. You say, oh, since I did one page already, then go on. Now, if you're tired, very simple one. Okay, if you're tired, very simple one. You just go to say, oh, I stop at this page. Then that's it lah. You did what you promised yourself. Am I right? One question. So why people feel defeated? Why people feel, tired or boring about studying? Because you overpromise yourself. You see, every time you do revisions, what you do? You just literally say, hey, today I want to finish chapter 2. You know not gonna happen, ma. Then when you do not finish your chapter 2, what's wrong? You feel bad. You feel defeated because why? You did not do what you promised yourself. So change the mindset, right? I do one question today only. Can I do one more? Can I do one more? Can I do one more? You always ended up doing more than what you promised yourself. Then you feel more motivated. You feel more comfortable and more happy revising yourself. Get it? So that's a simple trick here. So the objective, I give it to you one. I'm not doing. I just give this thing for you, right? It's for you to, start doing revision. You say, hey, today I feel very okay. Today I'm feeling a bit smart. I do one already. Then you go to front. Do this structural question. Again, tell yourself, not going to be a lot. We do one structural questions. Then when you finish already, you still got energy. You still got brain power. Do one more. Do one more. Do one more. Then rather than, when you do that, it's better than you just, cram everything together. Today I die must finish. When you tell yourself this kind of things, right? What's wrong? You're going to be super blur. You get it? You're going to be like, you feel very bad about yourself. You say, I don't want to do lah, very less motivated. So break down your task into small portions. Don't force yourself every day. This weekend, I cram everything. How about every day you tell yourself, today I do one questions. Tomorrow I do one questions. Can do more, do more. Then you can always finish earlier than what you have planted. Exactly. Okay. Now, so we go one by one. You got questions you can ask, sorry. I'll give you some checkpoint. So I explain detail for you. I let you know what is important. What is the thing that is you should know, you should not know. I mean, not important whatsoever. I clear out for you. So you don't have to blindly study things that won't come out. Right. Now, so 2.1. What is most important thing about these linear motions? You try to recall. Well, I asked just now, right? Everybody been through linear motion, right? This is the beginning of it. I think you sure did, right? I think no matter how slow your teacher is, at least you are in 2.3 now, right? There you go. So linear motions, right? 2 things. Okay, 2 things. What you have, right? Number 1, it's about the ticker tape. Okay. Number 2, right? It's about the linear motions. Okay, majority 2 different parts here in your linear motions that you learned before. Ticker tape and then the linear motions. Now, regarding this linear motion thing, right? Very simple one. I will call this as the SUVAT instead. The so-called linear motion equations, I like to call this linear motion. Now, what does it mean by this linear motion? Very simple one. Why is it called SUVAT? You look at the formulas one by one. You realize all the formula made of these 5 letters, right? S-U-V-A-T. S-U-V-A-T. So every one formula are made of this. That's why, make it easy for you to remember. I call this as the SUVAT equation. I call this as the SUVAT formulas. All right. We come back to that. Don't worry about that. So regarding this SUVAT, we come back for this. Next, right, we have this ticker tape. In fact, you learn ticker tape first. Am I right? So ticker tape, I need you to know 3 things. Exactly. 3 things. Right? You say, hey, I thought here you write 2. Where got 3, right? Now, that's the trick here. Here, right, for single tape, they can ask you 2 questions. For single tape, right, now we can separate them into 2 different questions. What are those? Simple. Number one, you got one tape. Okay, they give you one single tape, and then they ask you for velocity. Number two, right, they give you one single tape. All right, they give you one single tape also. Then why is it not becoming square? Wait. Then also they ask you to calculate accelerations. So that's why actually here got two lah, right? Question one, question two. And then where's the question three? Question three is over here. Ticker tape chart. What's ticker tape chart? Simple. It's many ticker tape. When you put them together, it's like, imagine this, you got a lot of them. You put them vertically. Then they start becoming this. You got the ticker tape chart. So all together got three questions. Also, ticker tape chart, right? They will ask you for acceleration or velocity only. Yes, so that's why I said three different types of questions. All right, single tape got two, ticker tape chart got one, altogether three. And then now, speaking of this, what is the biggest problem for ticker tape? Every time now, where you are stuck with, where is the blur part you have? It's always the time thing, right? Now, what do I say about that? Look at this. Can you tell me what's the formula for velocity? What's the formula for velocity? Basic one will do. We are not going fancy lah, okay? The basic one, the normal one. You do displacement over time, right? Okay, now what about accelerations? I suppose we learned before, right? You say you did free fall, you're supposed to know what? Final minus initial over time. Velocity over time is not wrong, but the more accurate one, final velocity minus initial velocity divided by time. We good? So you notice what is the biggest problem here, right? It's actually here. Both also got time, but the way you calculate time different. So this is where people get stuck. So I quickly remind you, later we can do a question to show lah, right? Now, first, regarding velocity, right? When you calculate time, what do? You calculate number of ticks. You calculate number of ticks. Whereas for accelerations, right? The time here, you calculate number of jump. Now, you might heard the different versions. Some of you say, hey, my teacher don't teach me this way. My teacher teach me calculate number of ticks. Then for the acceleration, right, calculate number of ticks minus one. Now, I don't like the ticks minus one method because some question doesn't work one. Some question doesn't work one. So it's actually very dangerous to think about it today. That's why to be more precise, we do ticks and then we do jump. Of course, you ask, hey, what's with these ticks and jumps, right? I give you one tape, I show you together. Okay, so imagine we got this one single tape. Okay, one single tape. So inside you have a lot of dot, right? Because your ticker tape, you start marking dots, dot, right? Now, question number one, you answer me now, okay? How many dots do you see? You try and count. How many dots inside the tape? How many dots inside the tape? I make it bigger for you. Come. How many dots? How many dots? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 dots, right? Number one, we never count the dots. Because why? You know how the machine works or not? The machine will do this tick, 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 tick. So how do you calculate the time? You go from dot, you bring up, you dot again. That one consider one tick. So the first dot normally you don't count one. So to prevent confusion, I will just tell you, don't calculate dots. What do you do? Instead, calculate ticks. Calculate ticks. How? Now in between the dots, you put a tick here. Like that, one time. Okay, now 2, 3, 4, 5, 6, 7, 8. How many ticks we have? How many ticks we have? We have 9 dots, but we only have 8 ticks. You see that? So for this case, right, if you want to calculate velocity, the time taken, what do? The time taken is going to be 8 ticks multiply 0.02 seconds. Okay? Now, later I explain the 0.02. Next, right, what about jump? How to jump actually? Now for jump, right, you jump from one tick to another tick, as in like this, one time. One jump. Okay, follow. 2, 3, 4, 5, 6, and 7. How many jump did we make? How many jump did we make? You notice they are different, am I right? Ticks, we got 8. But when it comes to acceleration, you want to calculate jump, they become 7 jump. Now, it will be 7 multiplied by 0.02. Obviously, the time will be different, right? So this is where people lost their marks. This is where people lose their marks. Because, you see, sometimes it's 8. Sometimes it's 7. It's the same tape, you know. But why is it so? Because ultimately, you are calculating different things. For velocity, what do? We calculate number of ticks. For accelerations, what do? We calculate number of jump. And of course, you ask, hey, what's with this 0.02 things, right? This one, right, is not exactly fixed, but usually is 0.02 lah. I tell you what, do you recall seeing this before? You know, ticker tape, normally they give you this frequency thing. Do you remember? Ticker tape, normally they will say like, hey, the frequency is 50 hertz. Seen this before? You know what does it mean by 50 hertz? When we say 50 hertz means what? Now, this one I explained to you, right? 50 hertz means, okay, in 1 second, you are going to produce 50 ticks. In 1 second. Every time counted in 1 second. One. So if I say I got 40 hertz, that means in 1 second, I will only produce 40 ticks. If I say I got 30 hertz, 1 second, 30 ticks. Get it? So since 1 second can do 50 ticks, what do? Simple. If I only want 1 tick, I take 1 second, divide by 50. You calculate for me lah. What do we get? 1 second divided by 50. What do we get? 0.02 seconds. Now, how do you get the 0.02? That is where the 0.02 come from. The 0.02 is because you have a frequency of 50 hertz. 1 over 50, 0.02. That's why, right, this one don't memorize. You know, I'm not going to tell you, say, never mind, I just remember 0.02 lah, right? Now, why is it 0.02? Because 1 over 50. Why is it 50? Because 50 hertz. So if it's 40 hertz, it's going to be 1 over 40. Then your time will not be 0.02. But normally, usually, it's 50 hertz one. And if some of the teacher will even tell you, say, you just memorize 0.02 lah. Confirm 50 hertz one. Most of the time, 50. But must it be 50? Not necessarily. Sometimes could be 50, sometimes could be 40, sometimes could be 30, whatever. If it's 40 hertz, then 1 over 40. You get it? But if the question never mentions, then assume 50 hertz as well. Only when they specifically say, hey, I want 40 hertz, I want 30 hertz, then you change. But no matter what, right? You see here, 0.02, 0.02. Why? Because 50 hertz. Okay? There you go. So that's why, right, when you calculate velocity, 8. When you calculate acceleration, 7. Why? Because velocity, you are calculating number of ticks. That's why 8 ticks. All right? Acceleration, you calculate number of jump. Now, do not, I know, you say, hey, this one minus 1 is jump, all right? Can I do that every single time? No. You just jump. You don't have to say, do I do 8 minus 1, 7 minus 1? Please don't. Very dangerous one. Later, I show you questions. You know it doesn't work. You cannot just, I calculate ticks and minus 1. No such thing. Okay? Ticker tape is for you to measure velocity one. Calculate velocity, calculate acceleration. Let's say you have a tortoise. You want to know how fast your tortoise moving. You put a ticker tape on the back, right? And then ask the tortoise move. So when the tortoise move, they pull the tape and then they start marking. So from there, you can calculate. You can get answer. You got it? So far? Can. All right. Now again, chart, same thing. Chart, same thing. Also, same formula. Velocity, calculate ticks. Acceleration, calculate jump. But the difference is what? For chart, right, they are going to have more rather than just one single tape. Now they got a lot of them. Okay. Now, up to now, slowly, okay, right? We slowly pick up momentum now. So at first, we start slower first. You okay, then I go faster. But don't worry, we make sure you're okay before we go on. Okay? Now, straight away, we try questions, then you know how to apply into everything. Now, by the way, there's a short notes here as well. I prepared a few of short notes for you to easily read through, and then a bit of checklist for you. You can say, oh, linear motion, what is it? You go through this. If you say, hey, this one look a bit blur to me, then you furthermore explain. You further go and find out more detail. Now, ticker tape also, as I said, you have 3 types of questions. Single tape, they ask you to calculate velocity. Single tape, they ask you to calculate accelerations. Single tape, they ask you to calculate ticker tape chart. The working, I know, now you listen, you understand one. Now you listen, you okay one. But then, when after that, you want to revise again, you can look at this working here. Okay, I make it very detailed already one, so it should be quite easy for you to understand. Okay, same thing here. Okay, step by step, all the answer I put for you already one. Exactly. Now, we move on some more. I show you a proper questions. How do they ask you in exam? Can you look at page number 7? Page 7, we do question 1 straight away. Okay, we use questions to learn as well. Q&A style. Then meanwhile, you know how they ask you in exam. Okay, so David carry out experiment in a lab to determine gravitational accelerations of a falling object First of all, do you recognize these? Have you learned this before? You know what is gravitational acceleration or not? First thing first, what's the symbol for gravitational accelerations? G, correct. And usually, what's the value? Usually, what was the value? You notice I use the word usually, right? Yes, 9.81. Because must it be 9.81? Not necessarily. Okay, but when we're doing calculations, they are usually 9.81. Okay, this one is the general value. When you do the usual ticker tape, when you do the usual subat questions, do this one. Okay, 9.81. But is it fixed 9.81? Not necessarily. Okay, and by the way, do you recognize the unit for this guy? You know why is it ms minus 2? Because it's accelerations. Now, gravity, bear this in mind, they will actually cause you to accelerate. I'll give you one simple example. You look at this calculator. You look at my camera, calculator. Now, if I hold the calculator this way, right, what is my velocity? If I just hold it here, what's the velocity? Am I moving? Not moving means what? Not moving means what? Zero, correct. Now, if I let go, what happened? It becomes certain value of velocity, right? So can I say I go from 0 becomes some number? My velocity 0 becomes something else, right? Yeah, we good? What happened? Now from 0 becomes some number. I can say I'm getting faster, agree? That's why, right? Gravity gives you an acceleration. The acceleration caused by gravity is called gravitational accelerations. Understand? And then one thing, remember, accelerations, right? Always we count in per seconds on. Every seconds, what happened to you? If I say 9.81 means what? Every seconds, your speed increased by 9.81. They don't do one time. This is the biggest problem people have. When you're doing this, when you're doing the suvat, whatsoever, you tend to think, right? When we say 9.81 means your speed plus 9.81, one time, that's it. No, it's every seconds we increase 9.81. So let's say we wait. We start from 0. Okay, 1 second later, 9.81. We go on, right? Another second, what happened? 19.62. Another second, what happened? 27.43. They add and add and add. This one means every second plus 9.81. Do you understand what I mean? So far, so good? Can Now we go through a bit more. The result show you already, and then you see ticker timer use vibrates at frequency of 50 hertz. That's why I said normally they tell one. And this is when you can tell me, right, what does it mean by this 50 hertz? Now we said that just now, right? What means by 50 hertz? What is the meaning of 50 hertz? 1 seconds? No. I want answer more than just 0.02. I want you to understand one. How do you get 0.02? At the first place, because 1 second, 50. But obviously, does it look like a 50 ticks here? No, right? Just one, just 1 or 2, right? So what do? 1 seconds, we divide by 50. What do we get? We get 0.02. That is where the 0.02 come from. Seconds. This one is what? Time taken for 1 tick. Time taken for 1 tick. Follow? Now we look at question number 1. A, what they ask you. What is the time of motion for each strip? Strip means one of them. Okay. Now, can I say 0.02? Can I say the time equals to 0.02? You look at the diagrams. Does it look like 1 tick there to you? How many ticks we have? No. They say each strip. 1 is enough. You look at this. You tell me how many ticks we have. Listen to my questions. How many ticks we have? Do we count the dots? We don't. You notice there's like a black color thing here, right? This one is the dot. And then it's always like that. Whenever we do ticker chart, right? You see, at the first place, you know how this thing works? Why you got so many tips? It was actually just one long tape like that. A very long tape. And then you cut them into pieces like that. Then the question comes, how to cut? Very simple. Every time when they cut, right, they will cut right on top of dots. So that's why you see, you get dots, you get dots, you get dots here. Because when they cut, right, they cut exactly on the dots one. Now, sometimes they are not so obvious because when you cut, right, half of them be gone. So you only got half the dots left. So you say, this one, do we consider as dots? Yes, you do. Okay. So there you go. And then one simple rules about ticker tape chart. You tell me now, how many ticks for this? How many ticks do I have? Now, we got 1, we got 2. Good. Right? How many ticks we have for here? No. I say already, right? We put ticks between the dots. So like that is 1, like that is 1. Okay? Like that is 1, like that is 1. How many? 2. How many here? 2. How many here? 2. How many here? 2. You realize, right? Every one of them got 2. Now, this is the rules when we cut. Confirm one. If you choose 2 ticks to cut, everybody 2 ticks. Of course, the question comes, must I do 2? Not necessarily. Not necessarily. Now, if this one 2, everybody 2. If this one 5, everybody 5. If this one 10, everybody 10. So your number of ticks might not be fixed, but it will be the same for sure. Your number of ticks will not be same, but it will be the same. So if I say 5 ticks, everybody 5. If I say 2 ticks, everybody 2. If I say 1 ticks, everybody 1. Do you get it? But of course here 2 right? So how? Everybody 2. So can you tell me what should we write here? What should we write here? 0.02 multiply by 2. Answer? What do you get? What do you get? 0.04. Correct. Are we good? Can got question asked? There's no need to be ashamed of. I mean, you can direct message me right? No one gonna see your question, message anyway, right? No one gonna see your message. It's all right. You don't have to worry. Say, hey, is my question too dumb? No. So now you know, right? Every one of them inside got 0.04 seconds. Okay. Next one. Another typical question also. Why is the ticker timer connected to an AC power supply? First of all, you know what's this? Have you heard of this AC thing? I think from 3 you learned before. AC normally come with a pair one. Who's the partner for AC? Normally, you got 2 person, right? AC, the other one is? AC, the other one? Yes, DC, correct. What is the difference? Some of you told me already. AC is alternating current, correct. Then what's DC? AC is alternating current, so what's DC? Direct current. Do you know the difference between AC and DC? Okay, now, let's say this is a wire circuit, okay, a basic one. If I put a battery here, now battery is DC. Batteries are DC. What means by DC? The current for them, right, only flow one way. They don't change one. They just keep flowing. Now, they be like this. They go from positive, right? They go 1 round, 1 time. Okay, then they keep doing this. 1 round, 1 round, 1 round, 1 round, 1 round. They keep doing same one. All right. Now, whereas, what if right now I got AC? Okay, what if right now I have why like this? What if I have an AC now? AC, right, a bit special. Why? Because the terminal keep changing one. Yes, you know why it's called alternating? Because they alternate. So what will happen is, actually, they'll be like this. From here, they do 1 round. After that, right, they will swap directions. Then they swap again. Then they swap again, and again, and again, and again. Yes, so the difference between AC DC is what? The direction of your current flow. Direct current flow 1 way. Alternating current flow 2 way. And the question comes, why do we put 2-way current for ticker timer? Very simple. Do you know this thing, how it works? Have you seen a real one before? Have you done the experiment, by the way? I suppose a lot of people did, right? You should, by the way. Your school confirm got one actually. Whether your teacher want to play with you or not is another story, okay? But definitely your school has it. Done it before? Or maybe your teacher do it and then show you. Right. How the thing works? You know why is it called ticker timer at the first place? The machines, right, when you turn it on, they do one thing only. They just tick up and down, up and down, up and down, up and down. Imagine, look at the camera, okay? This is the ticker timer. What it does, right, they do this. Exactly, it's called ticking. And you look at this thing, how many directions are we doing? You realize it's actually 2 motions, right? 2 motions. What am I doing? Simple. I do go down, go up, go down, go up, go up, go down, go down, go up, go down, go up, go down, go up, go down, right? So when you repeat this, notice what happened or not? They start marking the paper, dot, 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 dot. Realize that? Exactly. So what happened for this ticker timer? Very simple one. They just keep tick, 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 tick. And then look, how many direction are we having? How many direction is the ticker doing? Up and down, right? 2. And then look, up and down. You realize the direction is like opposite, right? And you realize they are very similar to your alternating current. Am I right? That's the reason. That's why we do AC, because when your current changed, your direction changed. So you see, current do one time, right? They go down. Then terbalik, they go up. They terbalik, 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 up, down, up, down, up, down. Exactly. You know what happened if they do DC? Do you know what happened if I put DC? What happened to the timer? They go one way only. And you know what means by one way? Like literally go down. That's it. So what will happen? You go down and then you drag all the way. You're not going to get dots. You just get one straight line. Understand? Because it's the paper being dragged. So your machine do this dot, 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 up, down, up, down, up, down, up, down, up, down, and then become your ticker tape, right? What happened if you put DC? What happened if you put DC? They'd be like this, dot, and then pull all the way. This is what you expect to see in DC. Get it? So this is why the AC. Questions over? Can. So now you need to explain yourself lah. Why are we using AC? And then this is when, right, you want to use some scientific words, scientific answers. If not, right, a lot of times you all like to use your pasar language one. So that the ticker tape go up and down, up and down, up and down. It's not wrong lah, but you know it sounds funny, right? So what do you call the up and down motion? There's a reason why it's called ticker, because that motion is called ticking. Yep. So what's that for? It's for you to produce continuous ticking motions. The so-called ticking motion is the up and down motions. Get it? So this one question that a lot of people that actually don't know answers one. You don't even know we are supposed to use AC. Why is that so? For this. Are we good? Can. Now, another kind of questions they like to ask, right? It's actually, they will ask you to describe the type of motions. The type of motions. Like what? You look at this. Can you tell me what kind of motions are we having here? Now, first of all, the number of ticks, same or not? The number of ticks, same or not? Ticks is for you to calculate time. So if I say the number of ticks same, means the time same. All right. And then you look at the length, how? Is it getting longer or shorter? Now, ticker tape chart got one good thing. It's the fact that every time, right, this is 0. Okay. How you draw a graph? You start from 0. That's why no matter whether your tape is long or short, here must be starting, here must be ending. Doesn't matter if even we have like, long become short also, then how? Here starting, here ending. We don't care about long or short. We look at 0 starting all the way to ending. Get it? Starting all the way to ending. So over here we have U, over here we have V. Okay. Now, what's happening? It's getting longer, right? Means what? You think about it. If I give you same time, you can travel more distance. What does it mean by that? Same time, you can travel more distance. You are getting fast or slow? Exactly, you are getting faster. So what kind of motions are we having here? What kind of motions are we having here? Getting faster, got one word to describe what, right or not? Getting faster? No. We don't say increasing velocity. Better than that. Increasing velocity, actually known as acceleration. Good. Okay, so what we're having here, it's accelerations. No, some of you tell me, oh, then can I write uniform accelerations? Now you look at these questions and tell me, are we allowed to put the word uniform in front? You know what means by uniform accelerations? Your speed increased constantly. And you think about it, if your speed increased constantly, right, what will happen to the length? It should increase constantly, right? You look at the length, does it increase constantly? First one is 2 cm. Then, now this is not 4. You look at it properly. Look. If you look at it properly, you realize one thing is, this one 2, correct. But then the next one you have is 3. Then the next one you have is 5. Then the next one you have is 6. Then the next one you have is 8. Are they constant? I suppose not quite, right? This one, you see, at first plus 2, then plus 1, then plus 2, then plus 1, then plus 2. Now, of course, you say, got pattern, man. No, this one is not considered pattern. You want to say uniform acceleration, you know what happened or not? The length is supposed to plus the same amount. Like you say, well, you want plus 2, right? Everybody plus 2. Plus 2, plus 2, plus 2, plus 2, plus 2. You want a constant velocity, right? Sorry, you want a constant accelerations, right? Plus 1, plus 1, plus 1, plus 1. Cannot say I plus 1, then plus 2, then plus 1, then plus 3, then plus 5. This one, yes, we are getting faster, and that is all. Acceleration, that's it. You write uniform minus what one? Yeah, cannot write uniform because they are not uniform. Uniform, your length should increase constantly. Every time increase 2 plus 2 plus 2 plus 2. This one, nope, so cannot. So far, so good? Can. So, of course, you say acceleration, right? They ask you to find acceleration from the chart. They ask you to calculate accelerations. Now, how do we start from this? How do we start with this acceleration thing? Always, right, make it a good habit. Start from writing formulas. Start from writing formulas. Now, I know you guys don't like to write formulas one. And no, it's not a big issue. You say, if I don't write formula, do they minus my mark? No, it's a good habit. It's a good habit. You write formulas, right? You know what is the problem? Sometimes, right, it's not that you all don't know how to do. Okay? It's you don't know how to start. A lot of times when I show you the first working, like the starting line, right? Then you can continue from there on. So how to start? Simple lah. You know, one of the way to start is always start from formulas. They ask you calculate whatever, you start thinking, hey, this one got formula or not? God, I write out. Okay, this one got formula or not? Of course you do, right? How do you calculate accelerations? Come, formula. Just now we said, right? How do you calculate accelerations? Final velocity minus initial velocity, then we divide by time. Got it? Then you ask yourself, do I have this? Do I have this? Do I have this? If I have all of them, I got answer. So at least you know what to do. All right? Oh, in order to find acceleration, what must I do? Find out V, find out U, find out T. Get it? And let me tell you now straight away, V and U will never be given to you. They don't fall from the sky one. You die need to calculate. Yes, I tell you now already. Okay? Whenever you want to calculate accelerations, what is the first thing you do? Calculate final and initial velocity first. This one sure need to calculate one. Okay? Confirm need to calculate one. Now, what was the formula to calculate velocity? This one first. At least you know this one. V equals to what? S over T, good. What about U? Actually, U and V both also velocity, right or not? Regardless, final velocity or initial velocity, you just displacement over time. Velocity, you just displacement over time. Now, some of you will say, hey, V and U is given what, right or not? If you look at this, the first one we consider U, the last one we consider V, right? Because starting final, right? Now, can I take the 2 here as my U? Can I take the 8 here as my V? Can we do that? Why not? Because that 2 is what? Look. What's that 2? That's cm. That's your length. So why they give it to you? For you to calculate, not to substitute straight away. You understand? Now you see, U is 2 cm, V is 8 cm. So what we're going to do, we put here, U is 2 cm, V is 8 cm. Am I clear? Are you still with me? Then what about the time taken? Simple. We are looking for velocity. We want to calculate number of ticks. How many ticks here? The 8 cm. How many ticks we have? The first question asks you already what, right or not? One strip, we have 2. What's the time taken? What should be the time taken? 2 multiplied by 0.02. Do the same thing for this one, because I said, right, once you found out one of them is 2, everybody must be 2. Then you can substitute inside, get your answer. All right. So always to find A, first step. Okay. Step 1, calculate velocity first. Step 1, calculate velocity first. Okay. Both initial and final. What's the answer for number 1? This one. 2 cm divided by 0.04. What did we get? I think you get 50, right? Is it? You calculate? I got no calculator. 50. Okay, good. Now 50, I believe you are. 8 divided by 0.04. 8 divided by 0.4, 200. Okay, good. We got 200. Settle. What is the unit, by the way? What's the unit for this? Now this is where you make mistake. Answer, the unit is what? CMS -1. CMS -1. Because some of you tell me MS -1. Now, normally, yes, you say, hey, I thought meter per second is SI unit. It is. But then you think about it, what did you do here? You take cm divided by seconds, right? So if you take cm over seconds, what do you get? You should get cm as what, right or not? Yep. Now, yes, normally for linear motion, for the subak questions, right? That one I'll tell you, meter per second all the way. They give you cm convert, they give you km convert. But for ticker tape, right, you are allowed to leave your answer in cm per second. Unless the question asks specifically, I want meter per second, then you convert. If not, it's okay to leave them in cm, because for ticker tape, right, your number normally very small one, 50 cm. If you count a meter, become like what, 0.0 something. So usually we don't. Okay, unless the question say, leave your answer in SI unit. That one you convert. If not, right, cm, it's fine. cm, it's fine. We good? So everything move over, we get what? Final velocity, we copy. Now that's why I say must calculate one, because after you calculate, you can substitute. Final 200, initial 50, and then divide by time. Now this is the main thing now. What is the second thing we do? No, it's not calculate answer. Second step, we calculate this. What did I say? To calculate time for accelerations, we calculate number of jump. Okay, because why? Now, only when you calculate accelerations, you need to calculate jump. Every other time, number of ticks. This one, why is it 2? 2 ticks. But here, jump, how to jump? Look. This one, how to jump? Now, please don't jump one by one now. Like you say, oh, this one I know, we jump one by one, we do this, 1 jump, 2 jump, 3, 4, 5, 6, 7, 8, 9, 8. This one easy, why? Because every one of them is one take, man. What if, right, they decided to play with you? Every one of them inside got 10 now. Every tape inside got 10. Then how many times you want to jump? Like you go like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, you jump until like what? Waste all your time. So this one, right, when it cut nicely for you, listen, when it cut nicely to you, you be smart. Make use of it. How to jump. Instead of jumping one by one now, what do? You go strip by strip. Like, walking up a staircase. Look here. How do I jump? You pay attention first. 1 jump. 2, 3, 4. Question number 1. How many strip do we have? You answer me first. In this diagram, how many strip do we have? Strip means the tick. 5. How many jump did we make? I got 5 strip, right? You see 1 strip, 2, 3, 4, and 5, right? How many jump did we make? 1, 2, 3, and 4. So now, right, look, jump 4 times, right? I will divide by 4, not done yet, multiply 0.04. Now, this is the one thing that you ask. Hey, how do you get a 0.04? Right? Simple. Now, how do you jump? You realize you jump from one strip to another strip, right? So the question comes, in a strip, how many time we have? What is the time taken for one of these? It's 0.04, right? So when you jump, what happened? 0.04, 0.04, 0.04, 0.04. How many 0.04 do we have? 4 of them. Understood? So that's the trick here. Can follow? Okay, good. That's the trick. Now you say, hey, why? Just now you jump, right? You multiply 0.021. Now, just now and now, what is the difference? I show you lah. Okay, then you can have a better comparison as well. You see, just now, the jump, right? We end up doing 0.02. That is because, right? Just now is one single tick. One tick, right? What do? Look at this. You're doing one by one. Realize that you jump from one tick to another tick. One tick to another tick. It's one by one. That's why 0.02, 0.02, 0.02. But now, right, what is happening here? When you jump the entire strip. Inside got 2. So now you're doing 2 by 2. It's like, sometimes when you walk up staircase, you can take 1 step at a time. And sometimes you're lazy, you skip 1 step, you go like 1 and then 3 and then 5. So same logic here. Now we're doing what? 2 by 2. So 1 tick is 0.02, 0.02, 0.02, 0.02. Now, right, 2 by 2, 0.04, 0.04, 0.04, 0.04. How many 0.04 we have here? 4. That's why we multiply the 4. You understand? Make a remark here lah. Right, what's with this 0.04 thing? This one is because the time for one strip inside got 4 ticks. Sorry, got 2 ticks. That's why the 0.04. And then ultimately, your final answer, it's going to be 150 divided by 0.16. Calculate for me. What's the answer we have? 937.5 cms, -2. Good, correct. Okay, so there you go. Every time, right, to calculate accelerations, not as hard as you imagine. Literally 3 steps only, right? Step 1, we calculate u and v. Step 2, we calculate the jump. Okay, step 3, we substitute and find answer. Okay, easy as 1, 2, 3. Velocity, jump, calculate. Are we good? Up to this point, everybody clear or not? Got question asked? No question, you give me an okay lah. Okay? Now, some of you perhaps will ask, hey, I thought the question asking to calculate accelerations, gravitational accelerations. So isn't it like the value 9.81? Why is it so much more difference? It's now, by right, according to what we learned, gravitational acceleration is 9.81, right? How come here 900 something? For one simple reason. What is the unit we normally used? What's the unit we normally used? They are meter per seconds. And what's this? cm per seconds. Actually, if you convert this, now the question never say anything, no need convert. They never say, hey, I 1 meter, then you don't convert. Leave it there, you are fine. But actually, if you convert, what do you get? 937 cm. If you convert, it become what? It actually becomes 9.375 meter per seconds. Now, you realized the number is similar, right? It's 9 something meter per second as well. There you go. Okay? So that's why ended up same thing one actually. But of course you say, hey, still what? Not same also, right? This one 9.8, this one 9.3. Way different what? Now, this is the question I want to ask. Why is it different than what you're supposed to have? Now, this one is your calculated value. Okay, you calculated this. This is the theoretical value. So why are they different? Think about it. They will ask one. Actually, they will ask one. So why? In real life, you will never get theory answers, right? Why is that so? Come you guess. Smart guess. Why is the answer different? The one we calculate and the one we read in books. Because you think about it, what's around us that will make you go slower? Exactly. Surrounding us, we have air frictions, we have air resistance. Air friction, air resistance, same thing one. Actually, same meaning one. So, simple. Theoretical value, 9.81. Whatever you calculated, 9.3. Why? Because you see, this one, how you do the experiment, you let it fall. So when it fall, right, your surrounding, you have air friction. They will kind of like slow you down. Friction slows down you. So that's why, right, the reason, very simple. Why is lesser? Because we got something called air frictions. Air resistant, air friction, same thing what I said already. You can say friction, you can say resistant, same. Okay, this is the reason causing the value to be different. Oh no, some of you tell me this, because we are at different location of the earth. No lah, and of course, when we have different locations, right, we are going to have different gravity, but they're not going to be different by so much one. Little bit different only. And by the way, do you know about this? Actually, when this one is what you learn in free form, right? You know, at different locations, we tend to have different frictions. Different friction block. We tend to have different gravity, different places of the earth. Now, the trick is this. The nearer you go to the center of the earth, the nearer you are to the center of the earth, you actually have stronger gravity. The further away from the center of the earth, you have a weaker gravity. Okay, now why is that so? Number one, you know earth is what shape, right? Earth, what shape? No, earth is not a perfectly round sphere shapes. A lot of people think earth is like that. No, it's not. And of course, it's not flat. Hello, what are you thinking? Flat is what? Flat is like people from few hundred years ago, that one they say flat. Okay, they used to believe Earth is flat. Yeah, like you go to the end of the world, you fall out of the Earth. Of course not lah, right? You know what happens if you go straight on Earth, keep going straight, you will come back to the same spot. That is a simple proof. You are doing wrong. If you keep going straight and then your Earth is flat, what happens? You go elsewhere already. So that's why by right, now everybody think Earth it's a round sphere shape. It's not. It's a bit flattened one. Not flat, okay? They are like this. Okay? Sorry. They are a bit like this. I mean, not so why got square one? Hello. Okay. Not so crazy lah, alright? But you get it lah. They are not like a perfect round shape. They are a bit like this. Slightly flattened. Okay? Oblong. Kind of lah. Now look, center point of the Earth. You see, from here I go to the side versus from here I go up to North Pole or South Pole. Do you think they have the same distance? Obviously no, right? Which one is further? The red or the blue? Further away. The red or the blue? Further means what? As I said just now, if you go away from the Earth, the gravity big or small? Further away. Can I remember? Think about astronauts. They leave Earth, they go to space, they start floating. Why? Because the further away from the Earth, the smaller your gravity is. So that means what happened to the red here? What happened to the red here? They are nearer to the center of the Earth. So what happened? They are stronger. But you see, even for the stronger, how much was it? It's around 9.83. Yes, and then this smaller, right? Also, not going to be so much smaller ones, around 9.878. Yeah, a little bit difference only. They're not going to go such crazy number one. So this only happens because of one simple reason, because we got air frictions. Can? No. This one no need memorize one. You know it's good already. When we doing calculations, theoretically lah, normally lah, maths lah, take this value, 9.81. We good? Can we go on? Anything else you'd like to ask? Okay. We put checkpoint now. Got question to ask. Don't hesitate. I move on. Now, if I move on already, then you want to ask the previous question, can also later after class lah. You say, hey, just now I'm not too sure, and then you move on already. So can you tell me why is it like that? Okay, after class I will stay for a while, so you can ask also. Because of air frictions. Yes, that's why it's different. Yep. The big difference is mainly because of air friction. So that means if you want this number, what must you do? If you want this exact 9.81, the theoretical value, where should you carry out the experiment? Correct, in a vacuum place. Some of you mentioned free fall. You know what means by free fall? You have to do it in a vacuum room. You have to do it in a vacuum chamber. Okay? Now, question C. Accelerations due to gravity. The one we say 9.8. They never say 8.1, but same thing, round off a bit. Explain what it means. What does it mean by this? This one actually very easy one. There's no need to focus too much on the gravity part. You focus more on to this. When we say acceleration equals to 9.8, it means what? When we say acceleration due to gravity is 9.8, means what? Your speed will, acceleration means your speed will increase, correct. But do we just increase one time? 0 become 9.8 and then just 9.8 all the way. What did I say just now? The acceleration, whether gravity or not, when we say acceleration, they are always counted in per second. 1 second, 1 second, 1 second. So 9.8 means what? 1 second plus 9.8. 1 second plus 9.8. So 9.8, 9.8, 9.8. They keep adding and adding. So the meaning of acceleration, that means what? The velocity of an object, okay, will increase by 9.8 meter per seconds every seconds. Okay, here you put how many? Come, question, test you a bit. -1 or -2? You read the whole sentence. Velocity of an object will increase by 9.8 ms minus 1. Why? Because what we mean is the velocity increased by 9.81 every seconds. So basically, this is what, look. Velocity every seconds. That's why you get accelerations. So this is the one thing that people always ask on, hey, why the unit why the unit is ms minus 2? I just get this question every single time, right? So what is the difference between velocity and accelerations? Velocity, right, it's displacement over time. So that's why you get ms negative 1. But accelerations, right, it's velocity over time. Means what? You already got ms minus 1, then you divide s again. That's why the ms minus 2. Okay, your unit on top already ms minus 1 here. Then you divide s again. That's the minus 2. So that's why over here when we say velocity increased by 9.8, that's why minus 1. And then every seconds. So that's why you get accelerations. Okay, are we good? Understand? Next one, the statement only true if the object is free fall. What does it mean by free fall? Some of you mentioned just now, right? We want the actual value. We want the 9.81, right? You must do free fall. What means by free fall? Free fall means what? Free fall means object falling under no air friction. Means what? Under effect of gravity only. No need to mention air friction whatsoever. Just tell them when the object falling under effect of gravity. Just gravity, no frictions, no air friction, no air resistance whatsoever. Just gravity. Then everybody fall with the same. Now listen, your falling actually do not affected by your mass one. Whether you're heavy or whether you're light, same. Whenever we free fall, everybody same falling accelerations. But of course you have to do it in a vacuum room. So in real life, you don't get that, isn't it? You say, hey, in real life, everybody fall differently also. Why? Because real life, right, it's, we always have this air friction thing. So when you got different surface, different size, you fall differently. Okay? But if you do it in a vacuum, I don't care whether a huge bowling ball or like a small feather or like a very tiny rubber plasticine, whatever, everybody fall, same speed. Okay? In vacuum. No, free fall must mention falling under effect of gravity only. Cannot write any other answer. Okay? Object falling with no air frictions, there's other reason that causing you to slow one. So you need to mention just gravity, nothing else's. Okay? Next, give two practical reasons to explain why the calculated less than theoretical value. The one we said, how come? We calculated 9.3. The theoretical is 9.8. I give you one reason already, am I right? What was the first reason? Because the surrounding air frictions, resistance also can, I say already, air friction, air resistance also can, causes the object to slow down. Okay, or you can say causes the object to fall with slower speed or slower accelerations. Okay, what is the other reason? I put a point here to let you know there's two different points. Exam note, don't write point forms, please. Full sentence. Like now, when I say point form, is some of you literally just say air frictions. Not good. Full sentence, because air frictions causes object to slow down. Okay. Now, physics, your grammar is not important one. You say my English very bad one. They don't. As long as your sentence can be understood, but write sentence, don't point form. I don't recommend. Maybe your teacher tell you can point form, but I don't recommend. Because when you keep doing point form, there's one problem. You become. Do we communicate with point form? Like, do you talk to your friends with point forms? So I want you to be able to, explain yourself. Sometimes you got this one problem. I know, but I cannot explain myself. Why? Because you point form all the way. So learn how to explain things in sentences. Second reason, anybody? Second reason? Try. They want two reasons. How? No, gravity is the reason why I got 9.8. No. Okay, I'll give you a hint. You know what is the biggest error that happens most easily when you do an experiment? What is the reason that you have error happens in experiment? The one factor that causes errors in experiment Most easily one. Exactly. It's you. What means by you? Human error. Human is always the biggest mistake one. When you do experiment, what are the human error we have? Human error got two. Human error is just general terms. You know what error do we make always in experiment? Two. Yes, number one, parallax. And you know, when you look at the reading wrong, by right need to look at it 90 degree ma. Then you look sangat like that, of course answer's wrong, right? Another, human error got two. Parallax error, the other one is called calculation error. Sometimes you calculate, then you chat, gone. Okay, your calculator wrong, gone. Okay, so human error you got two lah. Okay, parallax error, calculation error. But usually I will say lah, parallax error is the one that they're expecting. Yes, parallax error is the one that usually will happen. Yep. Okay. So second reason because okay, human error such as parallax error occurs during in experiment causes the calculated value to be different than theoretical value. That is your second point. Okay. Calculation no need to mention, just mentions human error such as parallax. Parallax is the one that happens most often. Calculation, not everybody calculate wrongly, ma. Some of you be careful, then can already. But parallax error is the one that often happen. So you got two reasons. Number one reason is because surrounding air frictions cause you to slow down. Answer not accurate. Second reason is because human error such as parallax. Parallax, you know what, right? Like this is your ruler. You're supposed to look at it this way, 90 degree. Then you look at the different angle, at the wrong angle. Okay. So two practical reasons, air frictions and human error. Parallax. Okay. We good? Any questions so far? Following? Come, we wrap it up because a little bit more questions only, then we can move on to another thing to explain. But so far so good, everybody? Can we go on? Hey, where's my yes? Okay, move on. Next, we have this. Okay. Last questions. Experiment is repeated on a planet with gravitational field strength twice the value on Earth. Draw the diagram. What is the expected ticker tape chart? Now, if you go to places with double gravity, what happened? Now, your experiment is you let the object fall and then they pull the tape. Okay, so obviously, if you let the object fall in a planet with ×2 the gravity, what will happen? Slowly, step by step. When you got gravity ×2 means what? Your falling speed how? Fall faster, correct? Now, of course, if your acceleration ×2, what happened to your speed? Also ×2, good. Now, if your speed ×2, what will happen to the length? Provided same time. So your number of ticks cannot change. 2 ticks means you keep it 2. Exactly. Now, simple math. This one cannot. Look at this. Velocity is what? Displacement over time, right? So let's just say I give them the same time also. Same time, constant, no changed. If this one ×2, what is it going to happen to this one? ×2 also, right? Because they proportionate one. There you go. So what happened here? What do you expect to see? All the length you draw ×2. Now look at this length properly. Look here first. First length 2 cm. Second one is 3. Then after that 5, 6, and 8. So you got 8 of them. That's why I say you cannot say uniform. They are all random length. So I write again. Now first one 2, and then 3, and then 5, and then 6, and then 8. Now this is the original length. Okay, I copy first. Easier for you to see. So here, look, this one is your original length based on the diagram one. No need to memorize. You don't do it yourself. They give by your question. So now what happened? Your new length, everything times 2 become new. Okay? So what do you expect to see? The 2 become what? 4. The 3 become what? 6. The 5 become 10. The 6 become 12. The 8 become 16. Right? So what are you going to do? Simple. Now, you look at how I draw first before you copy anything now. Okay? First one, we draw a 4 cm here. Then after that, we got 6 cm. After that, we got 10 cm. After that, we got 12 cm. And finally, we have 16 cm. Okay? So when you draw, this one agak draw one now. Okay? No need to say, oh, must I do properly now? First one, like that. Okay? 4 cm. Then the second one, right? Now, the dotted line is important. Yes, must draw. The dotted line is important, so must draw. So the 6 cm, I put it here. After that, 10 cm, I put it here. After that, 12 cm, I put it here. And finally, we have the 16 cm, we put it here. After that, erase off the dotted line a bit. This one extra, not needed. Pull away. This one also pull away. Push away. This one throw away. Throw away. Throw away. Throw away. Now, answer. Don't forget, put your dots. And now, the dot must be same because you want same time. Then only can compare Cannot say this one also increase, that one also increase, then how? So here, we have like 1, 2. This one agak draw one. No need to say. Must I measure properly in the middle? No lah. Okay. Before that, they give me 2 ticks. So now also I put 2 ticks. But the length become longer because your speed become faster. Okay. So that's your proper drawing. Understand? Most importantly is understand or not. Okay. The drawing you tak sempat to draw is okay one. You can just screenshots, then later you draw again. But are we good? Understood? Okay. Just times 2 4, 6, 10. Yes, this dotted important is the guideline to show. So it's better to draw dotted line to show that this one 16 cm, this one 12 cm, this one 10 cm. It's better lah. Your teacher minus mark, you're not that one need to see. Some teacher don't care, but I would tell you, you should. Okay? Can we go on some more? Can we go on some more? Not done yet. Done, right? Speed up a bit. If you're not done, then screenshot later because sometimes you want to take your own sweet time. Some of you got OCD, you want to draw a perfect line. That one I cannot wait for you right? Just take a screenshot and then we can go on. Okay, 5 seconds. 4, 3, 2, 1. Next. Take a tip. That's all you have to know. Everything detail I tell you already. Okay. Next, we got this one here. Linear motions. Now, actually, right, linear motions underneath, you can see I make it detail for you. Got 2 types. You got horizontal motion, you got vertical motions. Both, right, also using these formulas one. And you look, there's 4 formulas here, right? So you'll be wondering, hey, why do we need so many, right? Why can't just one formula settle everything? Well, you look at the formulas, you notice one thing or not? As much as we said the formula is made of these 5 letters, so what? Displacement, initial velocity, final velocity, acceleration, and time. You will notice one thing is, did we use all 5 letters inside? SUVAT, S-U-V-A-T. Did we use all 5? Not quite right. Not quite right. Now, look at the first one. How many we used? Or I should ask, which one is not inside? Among these 5 letters, S-U-V-A-T, you can read out and see. You can read out. You read out and see. What is it? S-U-V-A-T. Yes. Inside don't have A one, right or not? Exactly. So first one don't have A. What does it mean by that? If the question never tell you A, okay, listen, not asking. If they never tell you, okay, they ask, let's say they ask you calculate S, but they did not tell you any A. Use this formula. Simple what? Because you don't have, then how you calculate? right? You see, if you use other formula, you'll be stuck. You don't know what's the value for A. But first one, don't need worry because not inside. Okay, so that's why we have 4 different formulas. Okay, now let's say if I ask, right, I have a question, never give me time, want me to calculate S also, never give me time. What formula am I supposed to use? Which one? 1, 2, 3, 4. Which one got no time one? Which one got no time? Exactly. If you look at them, you notice, right, the fourth one do not have time inside. So then use that one. Understand what I mean, right? That's the trick of using them. And what about the fourth one? Sorry, the third one, sorry. Third one, missing out. What is it missing out? SUVAT. You read out, you notice S. And then the second one is SUVAT. What's missing out? V. And of course, you will notice one thing is what? As much as we got 4 formulas, we can have no A, no V, no S, no T. But no matter what, U, it's must have one. So confirm got U one. Okay, you say, by chance they won't give you. Nope, they sure give because every formula got U inside. Okay, so that's how we use the trick about this linear motion thing. Okay, 4 different formulas. To be quite frankly, your school got formula sheets or not, that one depends on your school. Some school give, some school never give. So normally I recommend one thing is what? Before you go for exam, let's say normally these 4 formulas especially, how to remember, half an hour before exam. Don't talk to your friend, right? Use that half an hour. What happened? Memorize this. You just read and memorize, read and memorize. You go into exam hall, first thing you do, write down the formula in your formula sheets. Sorry, in your test paper. Then you kind of like create your own formula sheets already. Okay. So this one, the night before exam, the day before or maybe 1 or 2 hours before exam, you memorize. You go into exam hall, write into your test paper, formula sheets. Okay. So that's what we do. Now, meanwhile, when you're learning, when you're doing revision, right, keep referring. You got this one review, right? Just refer to the formula. And while you refer, right, what you do, every time start from writing the formula down. The question asks you calculate, right? Then you start writing S equals to U plus V over 2. When you do that, you are also kind of memorizing. Because when you keep writing, your brain somehow will program inside one. You say, I roughly remember the shape how. And then when you memorize one last time, it becomes easy. Okay? Now, linear motion, actually, right, this one, see, horizontal motion is what you do in 2.1. Vertical, actually, right, is what you do in 2.3. That's why I say when you're learning linear motion, you are learning both, actually. 2.1, 2.3. Horizontal, vertical. The only difference, what is it? It's actually here. Vertical motions, you're going up and down, right? That one got one thing extra, the one we said just now, gravitational accelerations. What's the value again? Gravitational acceleration. What was it? Yes, 9.81 ms minus 2. Now, then it comes to one simple thing. Must gravity accelerate? Must gravity cause you to accelerate? Not necessarily. That would depend on your object. Where are you going? That's one thing. Okay. Now you have to see, depends on your object. Where are you going? Okay. Now you have 2 situations. Typically, you're going to have 2 situations only. One is what? Your object is jumping down. Like say you fall from a building, you fall from whatever. Okay. Your object is going downwards one. Can? Now, gravity, what directions? Gravity, normally what directions? No, I shouldn't say normally. Always. Gravity, what directions? You see, gravity, they don't care about you one, You go up, they go down. You go left, they go down. You go right, they go down. You go down, they go down. So gravity always go downwards one. You understand? And then what you need to do, very simple. You pay attention to this. Your object and your gravity, are they same directions? Are they same directions? Now, if they are same direction, meaning what? Simple. When their direction are same, the gravity will help you. What means by help you? Now, right, this one, it actually causes acceleration. So now you put 9.81 positive because you are going the same way as gravity. So we positive all the way. Yes. Now, another situation is what? Sometimes, right, your object don't go down first, right now. I can throw the object up first, right now. So here's the questions. What if now, right, I have an object that decided to go up? What if now I have object decided to go up? Again, gravity, what directions? They do not care about you. They always go down. So now what happened? See? Up and down. Realize they are opposite directions, right? So if you go against gravity, what happened? You go against, right? So they try to fight you. So gravity will try to pull you down. So now what happened? Your acceleration will become negative 9.81. So that's why it must gravity be positive 9.81? Not necessarily. You have to see your directions. Where are you going? Are you going same as gravity? Accelerate. Opposite of gravity? Decelerate. But no matter what, right? Pay attention to the number. They are always 9.81. You just have to decide yourself lah, whether is it accelerate or whether is it decelerate. That one follow directions. Understand? So far so good. Left, right, no. Because when you do left, right, gravity not into situation ma. Like you walking, gravity important or not? No lah. So that's why I say vertical motion only got this. Vertical means must be up, down one. Left, right will go to horizontal. Horizontal, no gravity involved. You just do this normally. Like you driving a car forward, backward. Do gravity slow you down? They don't. Right? You go forward, gravity not going to speed you up. You go backwards, gravity not going to slow you down. You just go. All right? That one depends on your car, your bicycle, whatever lah. You cycling. Horizontal, gravity not involved. Okay? We good? So far, can. Later we got time, I will do a question regarding these linear motions. Can we go on? A bit more. I explain about motion graph also first, then I go to questions if I have time, because motion graph I think a lot of people get stuck with. So better I explain. But can we go on? Horizontal motion is left and right lah. Bicycle, cars, that one no gravity involved ma. Now next, motion graph. Another problem, headache, right? First thing first, how many motion graph do you have? How many types of motion graph you have that you learned before lah? 3. Which is what? Displacement time graph. Yep, displacement time graph. Second, velocity time graph. Third one, acceleration time graph. Which one is most important in your motion graph? These two. Now, I'm not saying AT won't come out. I'm just telling you, right, ST and VT is the one that usually come out. For one simple reason, because AT, right, the information too little lah. Cannot ask you too many things. So usually they cannot come out like one questions. So this is why in exam they prefer do ST, VT. Which one harder? VT. Okay. So you hope that exam come out ST, then everything easy ma. Yep. Motion graph, simple. I summarize for you. You just need to know 3 skills. You can remember this 3 skills, you move on already. Now, what are the 3 skills we have? Straightforward. Number 1, you need to know how to describe the motions. They give you the graph, you tell them, what are you doing? Are you going fast? Are you going slow? Are you getting faster? Are you getting slower? Are you accelerating? Those kind. All right. Second, you need to know how to calculate the motion graph. And third, you need to know how to sketch the motion graph. Okay. And to be quite frankly, when you can describe and calculate, then they become sketch. Yes, they become sketch. Why is that so simple? Because you see, describe is what? I give you the graph, you tell me what happened. So you use the Bali's logic only, right? I tell you what happened, you draw the graph. Right, so describe, and you say, hey, then why need to plus calculate? Because some point, certain value you need to calculate one. Yes, you need to calculate. Now, you know what is the difference between sketch and plot? Sketch and plot. Plot is you do it properly one. You have to put the scale nicely, 0, 1, 2, 3, 4, 5, and then you put like X, 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 X. You draw straight line, right? Plot is like that. Sketch, right? You just draw the overall shape, and then the important time, important value that will do. So that's why describe plus a bit of calculate becomes sketched. Understand? I give you one more trick as well. How to describe. A lot of you, right? Your answer not detailed enough. You say A, you forget to say B. You say B, you forget to say A. How? Right? Now, for this describe thing, very simple one. I give you a format you follow. Every time you do this, right, your answer will only be very detailed. Okay? Now, I never see people get deduct mark because detail one. I only see one thing. You get deduct mark because your answer not complete. So how? Simple. Look. Describe here. Every time, right, ask yourself 3 questions. Every time. Ask yourself 3 questions. What are 3 questions we ask? Number 1, is the object moving or not? Number 2, where is the object moving? And number 3, how is the object moving? So literally, right, now these are sample answer for you. See, we can say the object is, the car is moving forward with constant velocity. See, question number 1, question number 2, question number 3. When you put the answer together, they become a sentence. Then there you go. Answer idea. Right, moving forward moving backwards with constant acceleration. So always write, you want to complete answers. Now you say, hey, but my teacher, right, only asked me to write this one, this all right. Now, your answer being detailed, no problem one. What you scared is your marking scheme. They want a detailed answer, but then you skip A, you skip B. So a full answer, a perfect detailed answers, A, B, C. Go inside lah. Moving or not, where are you going? And then constant velocity. Okay, so do that for every single motion graph. Then you are very safe. Now, regarding describe, let me point out a few typical common mistakes you all do. Usually where you're stuck with, number one, you like to confuse between two things. Okay, you like to mix up between ST graph and VT graph. Whatever you learn in ST, you put in VT, then you gone already ma. And then you know what is the biggest mistake everybody does is the fact that you like to use the same logic. Whenever you see the graph go up, you say the object go forward. Not necessarily. It has to depend on what graph you're getting. So let me make it simple for you. Okay, so every time, right, when we plot a graph, it's always y against x, right? It's always y against x, right? So need to understand one thing. When you see a graph doing this, what does it mean by that? Doesn't matter is it straight or not. Okay, can be this, can be this, can be this. Doesn't matter. Straight, curve, whatever. As long as when you see the graph is going up. Now listen, when you see a graph going up, we don't care about this. We pay attention to this, we'll do. When a graph go up, right, you know what does it mean or not? This one, if you translate the graph, they are trying to tell you one thing only. Okay, when you translate the graph, they are trying to tell you one thing only, which is what? Your y value increased. That's it. That's it. Yes. So pay attention. When you see graph go up, it means your y goes up. When you see graph go down, it means your y go down. Okay? When you see graph go up, it means your y go up. When you see graph go down, it means your y go down. So that would depend what kind of graph you're getting, right or not? Because why? I can have ST graph. Okay? And I can also have VT graph. Right? And it means very differently, you know. They have very different story now. Why? You see, first thing first, what does it mean when the graph draw this? What does it mean if I have a graph that do this? Now, rules number one, always make it a good habit is what? Read the y-axis. So here, right, what's my y-axis? S. So when the graph go up, it means the y goes up. When the y goes up, then simple. You look at the y-axis. What does it say here? S, displacement. So they tell you one thing only. What? And what does it mean by this? S go up. S is what? You tell me one by one. What does it mean by S? S stands for displacement. So when object displacement increase, what does it mean by that? Your distance become further. Are you moving? Yes. Where are you going? Where are you going? Only, you know, they give you that, you know, got more and more distance one. So this one, yes, you can tell them you are going forward. Okay, so for ST graph, yes, graph up, forward, graph down, backwards. But then what about this one here? What about this one here? VT graph. Now, same logic, you know. Now, make it smaller first, not enough space already. Okay, now, right, if I have a VT graph, means what? Same thing. Now, the graph looks exactly same, right? But different meaning, you know. Now, what happened? Same thing also. When the graph go up, it means your y increase. But now, if you pay attention to the graph, what does it say on the y? This velocity. So what does it mean if I have a y increased? That means v increase. What does it mean by this? What do you call velocity increase? Good, velocity increase. What means by that? A word to describe. Yes, this means you are accelerating. You understand? Does it tell you directions? Can I go forward with accelerations? Can I go backward with accelerations? Why not? You see or not? So that is the translations. Whenever you see graph up, understand one thing. It means your y up. Then look at y-axis. If it says S, it means you go forward because your S increase. But if it says Y, it means you accelerate because your velocity increase. Now you get the difference? So this is one thing that you always confuse with. Understand? Now we further elaborate some more. So how do you tell directions for ST graph, VT graph? I give you a summary versions. Whenever you get ST graph, right, they are like this. See, displacement time graph. Okay, usually you get one up, you get flat, you get straight. How do you tell directions? Now this one, yes. When you go up, when your graph go up, doesn't matter straight or curve. Curve also can, but normally if they want you to calculate, they will usually give you straight line because they will not ask you calculate any curve graph. Must be straight line to calculate. All right. So this one, yes, you can tell. Okay, when the graph going up, you are going forward. And I want to say, must everything go forward? Not necessarily. Forward, backward is only a general term. Depends on your questions one, they will explain on. Like think about it, if you have a lift, if you have an escalator, do you go forward, backward? You go up and down. So they will change depending on situations. Not every time forward. Can be forward, can be upwards, can be downwards, can be left, can be right. You follow your questions, right? So I give you general answers only. So that's why, right? Look, if it's ST graph, very straightforward one. Graph up, forward, graph down, backwards. So what about this part here? Smart guess. Graph flat. How? Simple lah. Up is forward, down is backwards. Never up and down. Never forward, never backward means what? If you don't go forward and backward, are you moving? There you go. So here we can say at rest. Okay, why is it at rest? One simple thing here. Why is it at rest? Because here, okay, your S never changed value, never increased nor decreased. This means you are not moving. Okay, understand? That's why there's always this one sentence. Remember, when you move, your S will move. Understand? No, that's why people ask you move your S. When you move, you go forward, your S increased. Your S will change. When you go backward, your S will decrease. So when do you not move? When your S never changed. Get it? So this is how you tell forward, backward for ST graph. How you tell forward, backward for ST graph. Up, forward, down, backwards. Very simple one. Okay? But what about VT graph? How do you tell forward or backward? I want to set this direction today. Once you get a direction right, everything's simple. How do you tell VT graph? Well, you see, think about your suvat lah. Just now I said, am I right? For physics, right? How do we tell directions? Like, up and down, left and right, up and down, left and right, forward, backward. You don't care about this. You tell me like suvat lah. When you're doing linear motions, how you tell something going forward or backward, going up and down. Exactly. You do positive and negative. Exactly. Now, so for VT graph, how to show directions? The value will do positive, negative. Okay. Now, if your graph located at the positive side, listen very carefully. We don't care what shape one. As long as they are located at positive side, simple one answer. You go forward for sure. Now, listen. It doesn't matter your graph do this or this. Okay. Or this. Or this. Or this. This. All of them forward. Why? Because you are at the positive side. Do you understand what I mean? Or here, everything here, the one that highlighted, I'm making nicer for you. I highlight all this you are doing forward. Understand? That's it. You see, I don't even bother draw any shape in it. Your graph at the highlighted part forward. End of story. Okay. That's how you tell. Actually, if you understand VT graph, they are easier because I don't even look at the shape. I just see they above zero. I just see they located at the positive side. I write forward straight away. I don't even bother looking at the shape. Forward. Okay. So if I say if I'm a negative side, then how? If the graph located here, negative, then simple. You are going back. Again, backward, forward is only general term I use. You have to follow the question itself. The question will tell one. So see, by chance, we can say this one left hand side, this one right hand side can also. You see the questions. If they say the object originally is going to the right side, positive is right, and then negative is left. They say the object originally is going up. Positive is up, negative is down. Understood? So now, right, anywhere negative side here, 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 the one I highlight means backward. Okay, so you want a backward for VT graph, you must be located here. That's it. Okay, see the difference or not? I say it one more time. ST graph, we see the graph up or down. Okay, we see the graph up. Go up or go down. Go up forward, go down backwards. VT graph, we see the graph above or below the zero. Positive forward, negative backwards. You understand? Now, what does it mean? What does it mean if we have the graph for VT and the graph go up? Flat, down. Listen carefully. Forward, forward, forward. The difference is what? When your graph go up, it means what? This one here. Just now I said, am I right? Graph up is Y increase. What does it mean by Y increase? Yes, accelerations, because your V go up. Understand? So what does it mean for this? They don't tell you forward, backward. They only tell you one thing. Your V decrease. That's called decelerations. And finally, what about here? Your Y constant means what? Velocity constant, literally uniform velocity. Why? Because velocity constant. Understand? And then one trick for you as well. Next time you see a VT graph only, straight line, regardless up or down, put a word in front. Uniform also can, constant also can. So basically here, uniform accelerations. Here, uniform deceleration. Here, uniform velocity. For ST graph also lah. If you see straight line, I give you a trick also for ST graph only. ST graph, right? Straight line means you can straight away write this word, uniform velocity. Yes. Now ST acceleration sure curve one. So you see straight line, only one reason, same speed. So this one is uniform velocity, not moving. Understand? So now you see, if you use the format I teach you, right, they become a sentence, am I right? See, here we are moving forward with uniform velocity. The object is at rest. Moving backwards with uniform velocity. Moving forward with uniform accelerations. Moving forward with uniform velocity. Moving forward with uniform decelerations. Okay, so that's how you describe your motion graph. Questions? Not done yet, but so far we put a checkpoint first. We good? Take a screenshot lah. If you want, take a screenshot lah. Or I mean, best if you could just write down yourself one time, because easier. I need to go toilet for a while. Wait for me for 2 minutes. Okay, I'm back. Are we done? Can we go on? Next, a bit more only. Let me finish up lah. Okay, I try not to overtime you lah. Okay, but we we do task-based lah. The idea is to finish whatever we're supposed to learn. Then you can do it yourself at home, right? The exercise. Okay, so next, describe, settle. We go to here. After that, I said already, right? You need 3 skills. One is to describe. Next is to calculate. How do you do calculations? Simple. Motion graph, calculation, very easy one. No need to use all the fancy formula again. For motion graph, we just need to do 2 things. Okay, 2 things. Like what? First, they calculate gradient. Second, they ask you calculate area. That's why the graph they ask you calculate must be straight line. Curve, no calculation one. Curve, we stop here. Only described. Okay? Calculations, I ask you to calculate 2 things only. 1, gradient. 2, area. Of course, you ask, hey, how to know what to calculate? Right? Simple. I give you a shortcut also. Every time you do calculation for motion graph, you draw these next to your motion graph. Then simple lah. No need to think lah. Because when you think, you confuse. When you think, you blur. So you put next to your graph, you follow that one. Okay? No need copy this. Later I tell you why. No need copy. Just look here, do. Alright? So we have this shortcut. It's called SVA. Why SVA? Because got 3 graph, right? ST graph, VT graph, AT graph. So this one is the escalator trick. Why do I call escalator? Now you think about it. In a shopping mall, we normally have an escalator to go upstairs, downstairs, right? And why say escalator? Because normally, right, escalator comes in a pair, right? It comes in a pair, right? Like what? Now, you will always have one escalator going down, and then on the other side, escalator will be going up, of course, right or not? One go down, one confirm go up, sorry, one go up, one confirm go down, right or not? That time you see, like, since when you go to any shopping mall, the escalator only goes up one. No escalator go down. Then how? The shopper, they say, oh, you want to go up can because you come here to buy stuff, so I built an escalator for you. Then you want to leave now, you don't want to buy anymore. Then you jump down from building. Where got such thing one? Of course, we need to build up and down, right? Now, same thing here. So we draw an escalator like that. One level, one level. Okay? One level, one side they go down, one side they go up. Now, this one up and down doesn't matter. You can draw left-hand side down, left-hand side up, your choice. Okay? I teach you one way to not confuse. Simple. You look at the arrow that goes up. You look at the arrow that goes up. Where does it start? Arrow that goes up. Starts from A, right? Starts from A, up, right? So the A reminds you of what? I already said you only need to calculate 2 things. Area and gradient. So if it starts from A, what do you think? A for? Hey, hello, I teach you physics, don't A for apple, me lah. That English, okay? A for area, correct. Then what about the other side? Since area one side, the other side must be area one side, the other side must be gradient. There you go. So with this trick, you'll never confuse yourself. So you can draw an arrow, okay? You want your arrow up also can, you want your arrow down also can. As long as remember lah, up it's A start, so area. Down is gradient. Area one side, gradient the other side. Okay? This one only copy, I give you already, short notes. Here. That's why these short notes it might seem short, but it pretty much covered the important thing you're supposed to know, right? And there you go, see? There you go. And you see this one, the bullet, then whatever I draw just now, doesn't matter what, as long as up says area, up says area. So I say left and right, your choice one. Then the next question, of course, you ask how to use. Now I know I know how to draw this, but I cannot use. I don't know how to use, right? Now, your trick is this way. Okay, so let's say now I have a ST graph. All right, now I have a ST graph. If I get a graph that looks like this, what kind of motions am I having? You tell me lah, because I told you the trick already, am I right? To describe graph, what is the thing we do? First, moving or not? Moving, yes. Directions? Where are you going? Directions. Forward, because the graph going up, correct. With ST graph, straight line means what? Uniform velocity, correct. Now, of course, since you said uniform velocity, right? Then, of course, they ask you lah, velocity, calculate for me. So here's a problem. How constant can, I already said uniform, constant, same meaning one, both also can, right? Then how? So this is when you throw in your SVA shortcut. Now how to use this? Very simple. Step one, right? You decide where to start first. Step one, you decide where to start first. How to know where to start? Simple. You look at the graph. What graph is given to you? ST graph. So you start S. Understand? Then what do they ask you to find? Who do they ask you to find? Find V, right? Where is V? You are here. You want to find V. Do you go upstairs or downstairs? Anybody upstairs? Down. Now, then how you go down? Which escalator do you take? You want to go down, of course you sit the escalator that goes down, right? Takkan you say, no lah, you see the escalator go up, so I run down the escalator this way. I know you do that lah, you know, when escalator go up and then you run downwards. Normal human with the right mind, we normally follow the arrow, right? What does it say on this side? Gradient, correct. So that means what? In this motions graph, if you want to calculate velocity, you calculate the gradient of the graph. Get it? That's the trick here. Can? Anybody? Never mind. We do a few more. Okay, relax. Because I just want to get you to understand what to calculate. Okay. So how, at least you know all the shortcut I teach you. You know what to do lah. You can know, oh, this one calculate gradient, that one calculate what. Okay. Now next we try again. What if right now I have another graph that says VT graph? What kind of motions is this? What motion is this? Moving or not? Yes. Moving. Directions. Why is it forward? Because your graph, it's at the positive side. With straight line means uniform. Graph up means Y go up. Graph up means Y go up. What do you call Y go up? Acceleration, correct. So here's the thing. You say acceleration, then of course they ask you, hey, calculate acceleration for me. A equals to what? Same thing. Step one, draw this next to your graph. Then, how do we start? Where do we start? We start from here. Why? Because now we're looking for velocity. Sorry, we are given V. Okay, we were given V. Then next thing, what happened? You want to find who? Who are you looking for? A, upstairs, downstairs. Which one? Downstairs, what escalator do we take? Downstairs, what escalator do we take? Gradient. There you go. That means you need to calculate gradient. Understand? So far so good? So far so good? Not done yet, because why? VT graph, I can ask you to calculate one more thing as well. It's S. Okay, calculate two things. Number one is this. Number two is, now you are moving. Okay, you are moving. So definitely they ask you to calculate distance, right? Now, same trick also. We were given velocity time graph. Okay? Who are you looking for now? Who are we looking for now? S is upstairs or downstairs? How do you go upstairs? You take the escalator that goes up. And what does it say? Yep. That is when you know you calculate the area. Got it? So we got two things that they can ask you calculate. If it's accelerations, you calculate gradient. If it's displacement, we calculate area. Area means what? The graph, you do this. You calculate the area between your graph and x-axis. Between your graph and x-axis. And then you can see what shape it is, right? Triangle. I suppose you can do that lah. So there you go. So you see, another thing that you can learn as well. For VT graph, you got two things to go through lah. One is to calculate accelerations. One is to calculate displacement. Accelerations, gradient. Okay. Displacement, area. Hey, this one, your maths, what? Triangle, come on. 1/2 times the height times the base. Right. There you go lah. It's now the shape you're getting is all the typical shape. Triangle, rectangle, square, trapezium. That kind. We good? Can? So this is trick. Now, never mind. One more thing. Finish up first. Lastly, now I have a AT graph. What do you think they ask you to calculate AT? Now, okay, I make it easy one like that. What kind of motions? Now, this one, I can say this one, you know why they don't like to ask you AT? Can you tell me what kind of motion is this? Okay, question number one. Am I moving? Yes, you are moving for sure. Because why? You're having acceleration. So if you're not moving, you accelerate, you become moving. If you're moving, you accelerate, you become faster. Right? But then, can you tell me exactly where are you going? Forward? Backward? Can you go forward with accelerations? And can you go backwards with accelerations? You realize they look exactly the same, right? Here's a problem. So you don't know directions one. But of course, what kind of motions can we say? You're moving, yes. And what kind of motion is this? Your A, it's flat. Again, uniform for sure, right? But bear this in mind, this is accelerations. You have is this zero accelerations? Zero acceleration is here. This one got accelerations one, but then what happened? Your acceleration is uniform. Okay, you are accelerating with the same rate. So what can they ask you? Well, look at this. What graph given? What graph given? A. Right, start from A. You know what? They can only ask you to calculate one thing, isn't it? You are here. You are here. Anybody downstairs? Anybody downstairs? You only got one choice, right? You can only go upstairs, which is what? Velocity. So that being said, this AT graph, right, can only ask you to calculate velocity. How? Area. That's it. End of story. Okay, so that's why, right, for ST graph, you can calculate velocity. For VT graph, you can calculate acceleration and also displacement. For AT graph, you can calculate velocity only. That's why I say among three graphs, right, which one hardest? VT graph. Because why? VT, you are in the middle. You can go upstairs, you can go downstairs. For ST, right, you are here. There's nobody upstairs one. Means they will for sure ask you calculate gradient only. And then for AT graph, you got nobody downstairs. You can only go up. So for sure, they ask for area only. Now this one area more simple lah. Your graph, your x-axis, you sweep the area between them. What shape is this? Simple. This is a rectangle. Correct. Then you can calculate area for rectangle easily, right? There you go. Okay. So altogether we have three different graphs: ST graph, BT graph, AT graph. Okay. BT graph hardest because why? Can calculate two things. ST graph can calculate gradient only. AT graph can calculate area only. Okay, come. Screenshots. Are we good? But you see, no need to memorize all this. Use the shortcut. SVA, everything settled. Can? Understood? Clear? Okay. Where's my okay? Okay, good. Move on. Now, so this one settled, and somehow you see here, I mark very detailed for you. Okay, here I mark very detailed for you. ST graph, I'll ask you calculate gradient only. Now, when I say NA means not available, means no meaning one. That's why for ST graph, they won't ask you calculate area. They won't ask you the meaning of NA means not available lah. Nothing will ask. All right. For VT graph, gradient is accelerations, area is displacement. The one I said lah. For AT graph, area is velocity. And then for gradient, not available, means nothing. Good. And then the shortcut over here. There you go. We good? Now, okay, you know why I like to use the escalator? You know why I like to use the escalator concept? Simple. Because, right, escalator, you got second floor all the way down to ground floor one or not? Have you taken an escalator before from here, like all the way down? Where got such thing, man? Right. So that's why, right? That being said, that's why you only got questions go one steps and one steps. All right. Means, right? You of course people will ask one, hey, by chance, they give me this one, they ask for A, they won't. By chance, right? They give this one, they ask for S, they won't. It's always one level up or down only. S can only calculate V. A can only go up one step. That's why VT graph can go up and down one steps. Understand? So that's the trick. Are we good? Can. Anything else? Question you'd like to ask? Okay, now let me give you one last thing now. Okay, now first few thing. Number one, the question behind the answer, you can go to TDC website to download the answer. After that, I'll upload one. Okay. Now second thing, if you like a replay of this, you say, hey, just now I zoned out for half an hour. I forgot the part already how. Or maybe maybe your exam is August only happening. You want to re-watch this video one more time. Now what you can do is you can go to my YouTube channel. All right, this one is my YouTube channel. Jiun Physics. I will put it there. You can watch it. Okay. Any other questions you'd like to ask? If not, then I suppose this is all we have to we can go through today. I'm not trying to hold you on for too long. I know it's 6 o'clock already, and then some of you say, hey, I need to go to dinner already. Any other questions you'd like to ask? All right. The answer you see, to be quite frankly to you, the question inside is all the very good questions. Please try and do. They are they are exam style questions. Some more, you see, I prepare essay question for you. So some of you say, hey, essay question I want to try, but I don't know the answer how. Answer provided. Okay. So this one question, please go through. Any questions you can ask me lah, right? Any questions? So I hope you guys learned something today. All right. So thanks for coming. That's it for today. I will hopefully see you. Bye-bye.